that, don't think of it as positive area, negative area, think of it as stuff that is being gained and stuff that is being lost.
So like you cut off a piece, cut something off something.
I think in real life examples, okay, picture this is the origin. Let's say this is somebody's stock portfolio, okay? So this is how, let's say this is how much interest I've gained. So if I put money in, I have no interest yet, give it a couple of years. Interest, and what happens here? My, not bankrupt, my investment starts to lose money. But notice, I've already got a pretty good nest egg, so that this little chunk that I've lost still doesn't bring me back to zero. In this case, I lost a little money, but now I'm back into the thing. Now you end up with something like this, and you picked the wrong stock,
I
okay?
don't know where it's going though, like.
Yeah, so things below just means I have lost whatever it is I'm talking about, okay?
Okay.
What's the, I don't know. I feel like for some reason I've seen something like this before.
You probably have. We've done an example or two that have negative areas and negative chunks to them. I mean, we talked about it last week, and we talked about there being positive areas, area above and below, and they cancel each other out, so this is no big deal. The fact that we're going backwards, I think, is what's messing with you a little bit. That you can actually have stuff down here that's positive.
Yeah.
Okay, good, all right, so there's the kickoff. There's the first idea with this fundamental theorem part 2. That we can define functions to be accumulated areas of other functions, or a function is defined in terms of an integral. Okay? Now, you had hinted at, let me go back to our original. Okay. You had used a word earlier, I don't know that you meant to, but you had used a word earlier. And I can't remember what word you actually used, but you're basically implying a derivative. Okay? This is a function, y'all, and we can do things with this that we can do with every other function. We can take his derivative. If he is a function, he has a derivative.
I was saying like, because we're using, we're trying to find the gain of X over a certain time, so like how much are we gaining?
Well, there's a difference. How much is not rate of
How-
change.
Well,
How is it growing? How fast am I gaining
Yeah,
it?
that's how I was, and so I have to like take a derivative.
So a good question would be like, every time I go up a unit, how much more area do I gain? Or what is the rate of change? And is it constant? If I go up 1 unit, do I gain the same amount of area every single time?
Yeah.
Really? All right.
No.
Let's start at,
Well,
this picture says start at 0, so let's start at 0.
I can say that.
Okay.
Okay.
From 0 to 1,
Yeah, good.
how much area have I gained?
2.5.
2.5. From 1 to 2, how much have I gained?
3.5.
3.5 more. From 2 to 3,
4.5.
4.5 more.
5.5. 6.5.
7.5, right, so I'm gaining 1.5 more than I did the last time I gained, but I'm not gaining 1.5 more.
You're getting 1 more.
I'm gaining 1 more than what I gained last time,
Yeah.
but I'm not gaining 1 extra block. Do you understand the difference in those two things? Okay. Let's take a derivative, just for funsies. Okay, if we're gonna call this a of x, I would like to find a prime. We might mosey in here in 40 minutes, yeah. But you got a kick out of that too. Let's do it. A prime.
So what's the derivative for the ancestor?
That's a great question.
They cancel each other out.
Good thought. Okay, if I'm gonna take the derivative of the left-hand side, derivative of a of whatever, I'm gonna need to balance that by taking the derivative of the right-hand side. Okay, so let's do the math. before I can take the or the derivative, I need to actually have this turn into a usable function, okay? If you would be so kind, let's do the antiderivative, let's do this.
We have t squared plus t into
From 0 to x, okay? Still cannot take the derivative yet, I need to go ahead and plug these things in, all right?
Oh, okay. So, 1/2.
Plug in x.
X.
1/2 x squared plus 2x minus 0, or derivative of 1/2 x squared, excuse me, plus 2x.
In theory, they don't cancel out, but if you're going, if your gain function to 0 is 0, then it really is kind of just,
Now we can take a derivative. Okay, we have something, if I just put this on a piece of paper and say take a derivative, what is it?
2 plus t. I mean, t plus 2. X plus 2.
X plus 2. So, did the derivative and antiderivative cancel each other out?
No, but kind of.
Yeah, they kinda did, kinda.
Kind of. But they won't always.
Well, why are we getting kinda, why didn't it just cancel each other out? What's the difference in where we started and where we stopped?
We're just lucky that.
What is the
function-
difference in where we started and where we stopped?
We don't have a dt at the end. We don't have an interval.
The only thing I noticed is that the t became an
Well, the
x.
function's just.
Oh,
the same.
okay.
It's the exact same function, we just turned the t into an x and we're
Yeah.
done. Is it that simple?
No. I'm just staring at the problem why it's not that simple. I wish it just would go away.
I stare at it long enough. Stupid problem.
3 minus 0.
Oh, what's the down which, the only reason is
Yeah, because the interval of 0 is 0, but if it's not 0 to x and it's another number to x, that doesn't make that equation equal to 0.
Okay, that's a follow-up question. What happens if it doesn't start at 0? So hold that thought, that is something that we'll need to address. Okay, take the derivative of that antiderivative. Okay, let's do it together, let's hold hands. Again, before I can take a derivative, we need to do this. Okay. What is the antiderivative of t cubed? Okay.
Then you change that to.
Think of it as t to the 1/2, yeah.
So
So then
it's 2t to the negative 1/2.
Antiderivative.
2t to
no, it's like this three.
blah, blah, blah.
Half or something. That's it.
3 to.
I couldn't remember if it's 2/3.
Yes.
Raise to the power 1,
Divide
3 twos, divide by the new power or multiply by the reciprocal. Okay.
It's taking an antiderivative and derivative
I
at the
just couldn't
same
remember if
time.
it's 2/3 or 3/2.
This is why you're making jumble because. Yes. Yes, I am.
All right, let's plug in x, that's the easy part. All right, I'm gonna get 1/4 x to the 4th plus 2/3 x to the 3 twos. All right, now minus, stick in 0 and we do get 0. Or d dx of 1/4 x to the 4th plus 2/3 x to the 3 twos. Okay, now we can take a derivative. Take the derivative of that.
X cubed plus the square root of x.
Well, the 3/2 and 2/3 cancel, so you get x to the 1/2 when we
Yeah.
subtract 1 from it, and x to the 1/2 is the square root of x.
And look,
Ta-da!
That is what we started with, except for the fact that the t's are now
X's.
x's. Okay? You did bring up an interesting point. We're starting at 0, and you know I like to baby step you. Just when you think you've mastered something, I like to hit you with the, haha, you think you know. All right.
I caught before. Caught me. I caught they before they caught me.
Okay.
Only younger people would understand this.
Give me a number.
3.
Other than 0, 3? Sounds good.
Good X.
Would you like to try this one on your own?
Sure.
Okay, I'll give you 1 minute. Go.
Do you have a watch on?
No.
No, I don't think so.
How much are you giving us?
1 minute.
Okay, I got you. My watch is fancy, has a
Well, you
sock.
want
Two-
this,
let's do
and I
2
wasn't sure if
minutes.
it was by your
2 minutes.
sleeve, and I just didn't see it, or I was just like.
I have a fancy.
You're burning time.
It's already done.
Really?
No.
Okay.
So. 30 seconds.
It's not possible. Oh, I understand.
10 seconds.
But you said 2 minutes.
5 seconds. 4, 3, 2, 1. Goodbye. All right. Get me caught up with where you are.
I'm done.
What is the antiderivative of cosine?
Sign.
Sign? Or is it negative sign?
Sine.
Ah.
Yes.
Please don't get your,
You just take a
Derivatives.
derivative, and then you say, I just take a derivative, and then it's like.
That's right.
So it's fine.
I was
Okay.
going sign. But
it
then I
is
was like,
sine,
why should
not
it be
negative sign, so if you said negative sign, shame on you.
But you're right.
Okay, let's evaluate that. All right, plug in x, plug in 3.
Plug in 3, you get a number.
I don't know what it is, but I can reach my calculator and get whatever it is.
Doesn't matter.
It's actually, all right, 3 is something slightly less than pi,
So it's like.
all right? So we're talking about sine being the y value, we're over
Really?
here, we're almost about, I'm picturing this as a small number, like 0.1.
Yeah, like
Tiny,
-1.
okay, it's almost 0, not quite. All right, let's take a derivative. What's the derivative of sine x?
Cosine X.
Cosine x. What is the derivative of sine of 3?
Doesn't matter.
Three?
It's a number. It's
I mean, minus
constant.
cosine.
Well, it does matter. It matters that it's constant, so what is his derivative?
0.
0. It is not the cosine of 3, by the way. I got that answer at Green City, okay? This, whatever it is, it's just a number, so his derivative is irrelevant. It goes to 0, so our answer was cosine x.
Ta-da. We had the same thing.
It's because he's doing more
Oh.
silly thing.
How would it change if I started at, say, 10?
It wouldn't.
Why not?
Because it's so
Because
constant.
again.
Because that second part, when you plug that thing in, it's just gonna give you, whatever that is, it's constant. And when you
That's a
turn right
trig.
back around and take a derivative, it's gone.
That's
Okay.
true. If you have something like that that's going with that, it's 0. What
It's.
do you say?
All right. Let's pretend like this one,
What is going to?
right?
Again.
Started at something.
Okay, I understand now. 'Cause again.
Give me a number.
Okay.
You
I
like
say
3, you like 3, yeah.
I don't know why I threw something.
Let's do 4, just for fun.
Okay, I see, so it's always,
Now, again, I'm picking this one because we've already done most of the work, so I'm gonna fast forward here. D dx of 1/4 t to the 4th plus 2/3 t to the 3/2, evaluated from 4 to x. Alright, we already know we plug in x, we're gonna get 1/4 x to the 4th plus 2/3 x to the 3/2. Now, stick in 4.
a number.
Yeah. 4 to the 4th divided by 4, so it's really 4 to the 3rd. Yeah. Plus, well, I'm doing this for fun. 4, square root of 4 is 2, 2 cubed is 8, so 16/3. I'm not even gonna bother putting these two things together because when I take a derivative,
Bye-bye.
they're both, whatever, it's just a number, it's gone.
You're the weakest link.
Okay, yeah.
Without X is God.
So now, we haven't done a whole bunch of examples, but the ones we've done lead me to believe that the type of function is irrelevant, and where you start is irrelevant, okay? Look at this.
He's just gonna throw something weird ass and it's gonna be not work.
Look at this. All right, go.
Okay.
Done?
Yeah. Okay.
You should be done.
Uh-huh.
Should have been done 10 seconds ago.
Uh-huh.
What's your answer?
Natural log of X.
Natural log of x. Very good.
Yeah.
I have to also say that you
Okay, here's something I want to point out. Now, in this particular problem, especially with natural logs, you gotta be careful. Number one, about the absolute value. The fact that we need the answer to be positive. However, this one is already understood to be positive because I can't head back into the negative numbers. All right, it wouldn't make sense. I can't go from one backwards to all that stuff that doesn't exist. I can go back a
If we
little
like
bit,
the
but not
one where
much.
we had natural log absolute.
Yeah, and if you really feel that way, you should put it on there, and it technically will be correct on this one to do that. Here's the other thing. What if I wanted to do this one the long way to prove it? Okay,
It'll be the same answer.
let's do it. What is the antiderivative of the natural log?
Oh, the antiderivative of the natural log is.
It's the absolute value of natural log.
No, what is the antiderivative of the natural log?
Oh, we don't know that.
We don't know that.
That's a good point.
We know the antiderivative of 1 over x.
Yeah.
That's natural log as an answer, but I have no idea what the antiderivative of natural log is. That's not something we learn in AB. Okay?
That's something that people.
So for me to try and do this using the old conventional way, I got nothing. I can't even take the antiderivative, but I do know that these two guys, the derivative and the antiderivative,
Kind of can.
they're kind of cancel. Yeah, they're kind of inverses. They're mostly inverses.
Yeah.
Right? So this is the right answer. And look, at no point did I bother taking an antiderivative. Okay, so something you may want to get down in general, really cool formula. The derivative and the antiderivative. Now I'm going to say A, like you did to say it doesn't matter where we start, to x of f of t dt, where this is any function you want to feel like putting in there, cosine, natural log, whatever. If I do this, what am I going to get?
X.
f of x. It'll be the exact same function you started with, the only difference will be that we have swapped out x's for t's. Doesn't seem very powerful right now, but that's gonna be awesome in a little while. Okay, does that make sense? Everybody feels good about that?
Sure. I feel good about it.
You feel good, you feel good, you feel good, Graham, you feel good? Alright, super Graham, feels good. Alright, now that you feel good about it, show me that you can use it.
I feel good.
Real quick, just do these, all of them together should take you about 30 seconds, okay? Good luck. Don't blurt it out. Okay, all those together should take you about 30 seconds. And scene. All right, what do we get? First one, go. Secant squared of x.
It didn't work.
Code didn't go everywhere.
No, you know the thing where you put like if it doesn't have any bench, you can sit on any can. And you can hold your weight because of the way it's
There must
shaped.
have been a dent there.
Yeah, it must have.
There always is.
There
It
always
takes a millifraction. We get- All right, second one, go. Good. Third one, go.
Sine
Wait,
x squared. Or sine.
it's squared. Sine x. Sine of x squared. No.
Why do you say that?
It should be something. It's the same, isn't it? Yeah, it's sine of x squared because it's f of
Wait a
x,
second.
not
Sine of x squared.
That's not just normal x though.
True, it's x squared.
Okay, so that doesn't matter. I don't know.
Well,
You get f
your
x,
statement,
so-
it's not just x, is true. I don't know whether that changes anything or not, but your statement is true.
I just didn't just.
Parallel formula. You get f of x, so the sine of x.
Sine of x squared. Okay? Let's prove it. Antiderivative. What is the antiderivative of sine? Negative cosine. Alrighty. Plug in x squared. Negative cosine of x squared minus negative cosine of 1. Alright. You all agree that I don't even bother turning that into a plus, that part's gonna be 0 right there. Alright, take the derivative. So what's the derivative of negative cosine x squared? What's the derivative of negative cosine?
Sine.
Positive sine,
Sine x squared, but
but
And so
not just X, so would we have to chain it?
I guess we would, wouldn't
Yeah, kind of. So, 2X. The 2X sine of 2X
we?
squared. Okay.
So our answer was not sine of x squared, but 2x.
Our
Sine,
formula doesn't work for them because it's just x, no x.
Because if it's not just X, if we're not going to just X, we also have to tack on the derivative of what that is.
okay, do you understand why the chain rule applies here? When you stick this in, you create a chain rule problem that wasn't there before. Well, technically it is, because when you chain x, you just get a 1, so there's an extra 1 tacked on, which doesn't really change anything.
So it's actually.
Gotcha, okay,
So now we know that.
big 3-star.
No,
No, you didn't. So let's call this g of x. So instead of going to just good old x, we're going to some other function.
Okay, so the sum of the function would be
Okay.
of x.
Well, the first thing we're gonna do is actually plug that in.
Yeah. So be f of g x
T times g prime of x.
times f.
Good, which is, if you remember from your notes, the definition of the chain rule. Okay,
It is actually.
kinda. The chain rule had
Except it
a
didn't have-
derivative right
because
there,
we're-
but it's close enough. Cool, all right, let's put it into practice. Last time I'll torch you, and then I think you got it. Then we can move on to phase 2.
Oh,
How many phases are there?
We'll have 2 for this.
3?
2.
Okay. Phase 2, heating of the world.
All right, let's see here. D,
Here's turn Irish.
Scottish.
Yeah.
That's the one that comes out when I should have been born Scottish.
what?
Alrighty, lads.
Let's go from say 2 to sine of x of, I like this one, natural log of t. What? Oh no, he didn't.
But he did.
Oh, he did.
So, these natural log, what is this thing? No, it doesn't matter. Natural log of sine of x
Okay.
times cosine x.
Yeah.
Oh,
Okay. A big whoop, whatever that is.
whatever that is.
Yeah, whatever that is, I don't know.
We'll figure out meaning for that later.
Yeah.
I'll leave that to the monkeys.
d dx of the integral from -1 to e to the x of square root of t squared plus 1 dt.
Okay, so you do the x
Square root of.
square root of
E to
E.
x plus.
Well, alright, be careful where you pause it.
It's
There's a difference between e to the x squared and e to the x squared.
Yeah,
e to the x
x.
squared.
Okay, which I'm gonna write as e to the 2x,
Yeah.
Yeah.
okay, plus 1.
Then take on
E
e
to
to the x.
Derivative of e to the x is another e to the x, so. Okay, last one, I think you've mastered it. Let's see. Then we can move into the second phase here. All right. Yep.
Oh no. Oh no. no.
What do you mean, oh no?
Oh no,
It's not
Oh,
oh
no,
no
we
here,
do
what is
the
this? Oh no.
the world's about to end. He's making a phase 3 of world domination.
Got it?
No, it's gonna take some time.
E to
Don't plug me like that.
Alright, e to the,
E to
I need to scoot that over.
the x.
E to the cosine.
E to the cosine of x
Yeah, they could have like negative sign x.
times negative sine x. That's not it.
Minus
Minus,
2 to the x.
To
No, no.
Oh,
2x, okay.
there's more.
To the 2x e to the x squared. Oh yeah, because you have to plug it back into.
we're just doing top minus bottom, same way we've done, just plug in the top, do your thing, plug in the bottom, do your thing, subtract. It's the same way we've done anti-derivatives last week, okay? Oh my goodness, what happens if there's not a good old number on the bottom?
We just subtract that number.
Whoopity-doo, whoopity-doo.
So, how many stars is this one gonna have?
Let me write it down.
One judged on stars.
Yeah.
That's 1 rating, that's a 3 rating. I'm guessing this is a 5.
If you really like formulas, I think we got it from this one, but if you really
Yeah.
wanna use a formula, we'll do that.
It's the same thing, except you just minus.
More detail.
Really what you're doing is you're minus the derivative of, no, you're minusing. Okay. Yeah.
Okay, and we're technically doing the same thing here, it's just that
A
when we
constant.
plug it in and take his derivative, it's a 0, so it knocks out whatever you decided to plug in.
Let me just. Oh, no.
There we go. Big glowing marquee.
Oh god. How many is that? 1.
Ta-da.
16. That's good, 16 out of 5 rating.
Yeah,
Is that IGN approved?
yeah. Alright, it is practice problem time, and I will say practice problem, the one I've got right now, it's a doozy. It is doozy worthy. Although, this is one of the ones that when you see it on the AP test, I am expecting 9 points. Right now, you're not gonna get 9. You might get 4, 3 or 4.
I was thinking.
But by the time the AP rolls around, this is an easy 9-pointer.